Salam and welcome everyone. So today we're going to be working on the question on the screen that says a sample of 6.56 gram of argon occupies 18.5 dm cubed at 305 kelvins. Calculate the work done when the gas expands isothermally. So the change in temperature equals zero. So basically what you're saying isothermally is that it's a constant temperature problem against a constant external pressure of 7.7 kilopascal until its volume has increased by 2.5 dnk. Of course, because an expansion, there's going to be an increase in volume. One thing you have to note when you're dealing with question like physical chemistry is that you're either given one of the two. You're either given um a constant external pressure or a reversible reaction. And this is or a reversible process. And this only occurs when you're asked to find work done. So you can be asked to find the work done for a reversible process in an isothermal expansion, or you're going to be asked to find the constant, you're going to be asked to find the work done when there is an isothermal expansion against a constant external pressure. Like in this case, we're given that. So you have two different formulas. So the formula for a question like this would be negative, okay, P external times change in volume. So this is all you need when you're solving a question that is an isothermal expansion against a constant external pressure. In this case, we know our pressure that we're given is 7.7 kilopascal or 7.7 times 10 raised to the power of 3 pascals, which is also the same thing as saying 7.7 times 10 raised to the power of 3 Newton per meter squared. Because basically Newton per meter squared is the same thing as just Pascal. So that is the first thing you have to note. Now, looking at this question here, we see that work done, okay, is has the units in has its units in joules or Newton meter. So what I'm trying to explain to you here is that when you're given a question, before you can input the fact that you have the pressure or the change in volume, which is 2.5 dm cubed, you have to make sure that you have the units in the right form. You can see now we have the unit for pressure to be Newton per meter squared. But then we have the unit for change in volume. We have 2.5 dm cubed, by the way. We have the unit for volume to be in dm cubed, decimeter cubed. We cannot calculate a question when one is in a unit dm cubed and the other is in a unit of just meter. So what we have to do is we have to go from decimeter to meter. It's just like you being given a question where part of your question is in kilograms and the other part of the question is in grams. You need to change either from grams to kilograms or from kilograms to grams. Or sometimes you'll be forced to change from one unit to the other, and you can't just pick either of the two depending on the question. In this particular case, we'd have to go from decimeter cubed to meter cubed for volume. We cannot just use decimeter cube and input it in the equation. So what this is telling us is that we have to go, we have to solve what 2.5 dm cube would be in meter cubed. So first of all, we have to remember the basic maths we did in elementary or middle school. You have 10 decimeter equals 1 meter. Hence, 10 decimeter cubed would be equal to how many meter cubed? I'm giving you this standard information because this is what you use. Just like 1,000 grams equals 1 kilograms, right? Hence, 10 decimeter is going to give you 1 meter. So yeah, that's just basically how it works. So in this case, we have to cube it in order for us to go from decimeter cube to meter cube. So you have 10 decimeter cubed, the same thing as 1,000 decimeter cubed, and then 1 meter, all in brackets cubed, the same thing as 1 meter cubed. So now we're going from 2.5 decimeter to meter cube. So that would be using dimensional analysis. We have 2.5, okay, decimeter cubed times 1,000 decimeter cubed and then 1 meter cubed up top, of course. Yeah, and then 1 meter cube of up top. So we cancel out the decimeter cubed and decimeter cubed, and what we end up with is 2.5 divided by 1,000. So that'll be 2.5 times 10 raised to the power of negative 3 meter cubed. And this is basically the answer for volume. So now we can be comfortable enough to input this information because, as you can see, the unit for pressure is Newton per meter squared, and the unit for volume is in meter cubed because they are both in um some form of power of meter. We can use this information. So work done equals negative PEX or negative external pressure times change in volume. So hence Work done is the same thing as negative. What is external pressure? That's 7.7 times 10 raised to the power of 3 Newton meter squared. So that would be 7.7 times 10 raised to the power of 3 Newton per meter squared. So that's it. And then we have the change in volume to be times 2.5 times 10 to the power of negative 3 meter cubed. Of course, because of we know how things work, we see that we've got meter square at the bottom, we got meter cubed at the top, so we cancel the meter square and we cancel just the cubed, and we have just Newton times meter, which is what we would want anyways, because the unit for work is joules. So Newton meter equals joules, or joules equals Newton meter. So we're trying to basically see that our units are in the proper form so we can continue safely to put this information in the calculator. So negative 7.7 times 10 to the power 3 times 2.5 times 10 to the power negative 3 would end up giving you negative 19.25 Newton meter. Now, if you look at our question, we would see that where the pressure as well as the change in volume is in 2 sig figs. So we have to put our information up until 2 sig figs. So hence, what work done actually is negative 19 Newton meter, or work done is equals negative 19 joules. So whatever you're using in terms of unit, you can use Newton meter or you can just use joules. So this is basically the answer to this question. If you're confused about what I did, what I just basically did in this question, because it's a very easy question, is for you to just write, for you to first of all determine that the formula we're supposed to use, and because it's an isothermal expansion at that is occurring against constant external pressure, this formula W equals negative P external times change in V is what you're going to use. The next thing we did is to put pressure under the unit, as well as change in volume, the unit for volume under the unit that is going to work for us. When we properly converted the units into the standard units that we can use for this calculation, we substituted the values, and then we just did unit cancellation and we put information in our calculator and we assigned the right units for work. That's basically what you do. Half of the work here is unit conversion, the other half is just knowing the formula, and then you get the right answer. If you have any questions, please put it in the comment section. If you would like to suggest any question or any topic to do, put it also in the comment section. If you would like personal tutoring and you're a student who is trying to get an A and to succeed, whether you're in middle school, high school, or college, or you know anybody who would want to, make sure you email me at shohabitutoring@gmail.com. I am the tutor for students who are striving to succeed in their academic life. So if you have any questions or if you're trying to book a session, don't forget to email me at shohabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.